Okay, so looking at number one, remember always in a T-chart or in any kind of data chart like this, these are your X's right here, and these are your Y's. And of course, on your X in your table over here, this is your X's and this is your Y's. And so they've already plotted them for you. You didn't have to do that. They've already got it kind of drawn in that it's basically a quadratic shape. Okay. And so then it says, what does the y-intercept of this function represent? Well, the y-intercept represents, right, y is time. So the answer is going to be the time it takes, but the y-intercept specifically is what in age? If that's 10, 20, 30, 40, what would this one be? Be 0. So even though it's a far-fetched, it's not a realistic answer, but the answer of what the y-intercept represents here is the time it would take a newborn, right? A 0-aged person. If you want to put a newborn, if you want to put a 0-age person, it doesn't matter. But the y-intercept represents the time. We know y-intercept represents time because it says right here, y-intercept represents time. So the y-intercept represents the time that it would take and then you always reference the other intercept. And we've talked about this the last time we were interpreting graphs. When you're interpreting graphs, you always reference both. The time it takes for what? The y-intercept and the x-intercept. You always use both bits of information to explain what's happening. So the time it takes, or the time it would take a newborn or a 0-age, I don't care how you put it, to complete, and I'll just put the, 8K? The 8K. Okay? That's what it represents. All right, so then it says, using the model, what would be the time of the fastest 18-year-old? Well, again, they tell you that y, right here, they tell you in this model, here's your model, they tell you that x represents age and y represents minutes. So, I hate when it does that. If they give you the age, that's the y, you have to find, if they give you the age, that's the x, you have to find the time. It asks for the time. So you would leave y as a basic y, and then you would take that model, 0.00986, and in place of x, you're going to put a 19 squared minus 0.6 times 19 plus 36.4. Run it through your calculator, okay? Square 19, take it times that long decimal, minus 0.6 times 19 plus 36.4, and you get, and it says round your answer to the nearest hundredth. You always want to pay attention to that. And so we get y equals 28.56 minutes. 28.56, and you always want to label anytime it's a story problem. You want to label y is minutes, so 28.56. Okay, the second one still gives you another age, so same thing, right? You're going to take your equation and you're going to plug 75 in for the x because the x is the age, minus 0.6 times 75 plus 36.4. And when you do that, you get that y equals 46.86. So 46.86, again, we're rounding to the nearest hundredth, and we're labeling minutes. Now, this one is the one I really wanted to cover because this one is typically the one that throws everybody the most. So this time we're given the minutes, which is the y. So 27.7 is the minutes, or the y, equals. Then we're going to take that big, long equation. Okay, the only way to do this is the quadratic formula. So it always has to be set equal to 0. So the first thing I did was I subtracted 27.7 from both sides, and I got I worked it already. What'd I get? 8.7. Okay. Now, that's 0 equals. You have it set equal to 0 like you want. When a quadratic formula, right, you have, and I'll just kind of be lazy here, this right here is the A, 0.6 is the B, and 8.7 is the C. right? A equals, B equals, and C equals. So, and it looks uglier than it is, please use your calculators for this, but it's X equals negative B, which is negative 0.6 plus or minus 0.6 squared minus 4 times A times C all over 2 times A, which is 0.00986. Okay, that looks like a lot, and it is, but use your calculator. So when I plugged just underneath the radical in my calculator, nothing else, I'm going to leave that point or negative 0.6 alone, plus or minus. When I put all of that underneath the radical in my calculator, I ended up with 0.016872. Okay, that's what I got when right here, when I just simplified this part right here, this is what I got. And then when you simplify the underneath side, I got all over 0.01972. Again, this looks really ugly. You need to work this twice because it's one with a plus and one with a minus. Okay, so if you actually input into your calculator negative 0.6 plus, give yourself a radical sign, put 0.016872, hit equals, and then divide it by 0.01972. It's a lot of numbers and a lot of decimals, but it actually comes out very easy. You get X equals 37.0 something, but it said here to round to the nearest tenth, so it would be 37. 37 what? X is years old. Then when you clear out your calculator and you punch in negative 0.6 minus underneath the radical 0.01672 equals, and then divide that by 0.01972, you get 23, sorry. I was reading too fast. 23.8 something something, but you rounded the nearest tenth, so it stays 0.8. So that right here, or remember when it's a quadratic, you get two answers. Okay, those are the two ages where you would average 27.7 minutes. Okay. All right, so go ahead now that you kind of see a basic example of how to do these, go ahead and work through number 2 and number 3. They're identical as far as asking you to plug different stuff in. And then 4, 5, 6, 7, and 8 is just constructing scatter plots and then saying whether or not they are linear, quadratic, or exponential. Yes?
Negative 6 is already negative, so wouldn't that negative make it positive? Two negatives.
Yes, and I did it on my, you're right, thank you. I did it on my paper, but I didn't. It's negative 6, and so here it'd be negative 6, which would make that positive. Thank you for catching that on here. I did it when I worked it on my paper to get the right answer, but I just didn't drop it down there, so thank you, Luke. All right, any questions on that? All right, go ahead and work through the rest of the packet for tomorrow, and then we'll go over it tomorrow.